This video will look at some approximation or bounds for a circle. So I have a circle and I had the center, and we talked about earlier a relationship between the radius and the circle. The question is, how is this relationship work, and so on and so forth. So this could be questions the children have. Why is this? We talked about last time 7. This is 7, this will be 44. And they, yeah, but why, right? So we are going to take a general radius r, and then we are going to look at if we can make a shape inside or outside. So if I make a shape, for example, a simple shape, and this one will just take squares. If I make a simple shape square inside the circle, then clearly the perimeter that's going all around, right? The shortest point, the shortest distance between any 2 points is a straight line on a plane, right? So this is going all around, so this is longer, 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 and anyway the square is inside the circle. So definitely the perimeter of that square is going to be less than the perimeter of the circle, right? Similarly, if I had a square that is outside the circle, then the perimeter of the square on the outside of the circle will have the upper bound, because the circle is inside the square and I have to go all around. So obviously I'm not touching all, not taking the shortcut from here to here, I'm going all around it, right? So in this case we can see for the larger bound it's easy. This is r, then there are two r's in every side, right? So this is 2r, right? 1r here, 1r there. So all around I have 4 of these. This is r, this is r, this is also 2r. So the perimeter going all around is 8r. So we know that, you know, the perimeter of the circle has to be less than this 8r. Okay, it's less than this 8r. 8r coming from the perimeter of the big square, right? And similarly, if we look at the small square, I'm just going to draw it brown. If I could find the perimeter of that, how do I find the perimeter of that? Okay, so this is a right angle triangle, right? And in this right angle triangle, this is 90 degrees. The way I have drawn the square, this is 45 degrees, right? I've drawn it at a diagonal. So if as I have drawn it at a diagonal and it's all symmetric, I know that's 45 degrees. Okay, and we know that this is radius. We also know if this is 45 degrees, this is also 45 degrees, because it's 90 degrees. I remove 90 degrees, then I have 90 degrees left in this triangle. If this is 45 degrees, this is 45, this is 45. Not only that, these two are the same, right? So this is like a regular square that has been cut into 2, right? And so if this length is 1 and this length is 1, this length is root 2. This is a 1, 1, root 2 triangle. And so if I want this to become 1, I have a square in which this is 1, then each of these has to be divided by root 2. Okay? So basically then this length is 1 over root 2 from here to here, right? So that means 1 over root 2 of r. So this full length from here to here is 2 times that. So that is 2 over root 2 times r, root 2r. 2 is, remember, root 2 times root 2. So one of the root 2's will get cancelled, the other root 2 is still there. So this is root 2 times r, there are 4 of them. So you have 4 root 2 times r. This is my perimeter of the square inside the circle. So then we know that the circumference is greater than 4 root 2r. Remember, root 2 is approximately 1.414. 4 times that, 4 fours are 16. Right, sorry. So 4 fours are 16, 4 ones are 4, 5, 4 fours are 7. Well, I shouldn't really be doing it so accurately, but anyway, it doesn't matter. 4 plus. So it's more than 5.6, right? And it is also less than, behind this, but because 8r came from there. 8r. That still stays 8r. So this is starting to create bounds, right? As the children get older, they may have questions about why we accepted all this, right? And then at that point, you can start looking at how can you create bounds based on the shapes you know. So this was a bound we created based on squares. We can have better bounds as we keep increasing the number of sides so that it gets closer and closer and closer to what the circle looks like, both on the outside as well as on the inside.